I don't even know. And thank you. And good morning. Okay, so number 2 says find measure of angle B, and I'm going to mark it physically with a little arc so that I can make my angle from my arrow from that to the side across, which is 7. That is the like wonkiest arrow I've ever made. Hold on. I think it's because this triangle is like super skinny. But this goes across to the 7. And then the 50 is across from the 31. I don't know why that was so challenging for me. Okay. Sine of 50 degrees over the side across, which is 31, equals sine of B. So remember in this one, we're finding the angle. So the angle is the variable, which is across from the 7. Okay, now cross multiply. I like to put the variable in the front. So I'm going to do this side first. So 31 times sine B equals 7 times sine 50. Does everybody see my cross multiplying okay? Okay, now my goal is to get B by itself. So the first thing I'm going to do is divide by 31 on both sides. Here's my next question. How do I undo sine? Anybody remember how to undo sine? Sine inverse, right? And I usually don't show the inverse both sides. I just put B degrees equals sine inverse 7 times sine 50 over 31. So I'm sine inversing both sides. Sine and sine inverse cross out on the left. So we only show it on the right. And you can type this all into the calculator in one fell swoop. Sine inverse, which is second sine, 7 times sine 50 divided by 31 is 9.96. It says round to the nearest tenth, so I'm going to say 10.0 degrees. Does that look right to you guys? Anybody else get the same thing as me? Okay. So now we have reviewed both types of law of sines. There's the type where you find the side, and this is the type where you find the angle. And this is very similar. So this was the type where you find the side of law of cosines. And this is the type where you find the angle. This says find measure of angle C. So I like to mark it visually with an arc and then draw my arrow across to the 17. That helps me remember that the 17 is what should go in front in the law of cosines. So this is side, 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 which is law of cosines. 17 squared equals 18 squared plus 30 squared minus 2 times 18 times 30 cosine of C. Okay, Now, if you're going to mess up this problem, it's going to be order of operations. So we start with the 17 squared, which is 289. And then I like to put little brackets right there to show that I'm going to combine those two, 18 squared plus 30 squared. And then I'm going to show little brackets that I'm going to combine those three. Okay, the biggest mistake students make on this problem is they combine unlike terms here, and you cannot do that. This is like an X. So rescue the 1224 out of there before we do something dumb. And violate order of operations. So 289 minus 1224. Now divide. And when I come over here, I'm just going to make these positive because there's two negatives that make a positive. And then I'm going to cosine inverse both sides, just like the previous problem, but it's cosine. And both of those ended up kind of nice, and that doesn't usually happen, but that's okay. You guys did several of these first semester, correct? So there's four different types of problems with log sines and log cosines, and we have represented all four in the first four warm-ups. So that's like a full review of that topic. So log sines to find a side, log sines to find an angle, log cosines to find a side, log cosines to find an angle. Just so you know, if you ever need to look back, this would be a great place to look for an example of each kind. Okay. We are not writing anything else in the packet, so you can just scooch that aside and grab your notebook. And go ahead and set this part up. So the first part we're going to do today is sort of a review, just kind of a condensing all the things we learned yesterday. And then we're going to do problems 24, 25, and 31. Okay, everybody. So I want to review what we did yesterday. I'm going to start with this factor. So the first thing I'm going to do is talk about the vocab again. This is called a factor. It's a factor because it's in parentheses. A factor will give us x equals +2. So remember, when you take anything out of parentheses, zero product property, you change the sign. So it's +2. And this is called a root, zero, or solution. And roots, zeros, and solutions give us coordinates that we can plot as an x-intercept. I realize I'm being very, very specific, but that's okay. This one is a single root, which means that it does not have an exponent on it. So it's like to the first power. And when you have a single root, so just graph the x-intercept to 0, your curve, whatever's happening to it, is just going to go through that spot. So if it's just a single root, your curve just goes through at that spot. You guys remember doing that yesterday when we were drawing our like wavy graphs, and the single ones we just went through. Okay, but the double and triple ones were special. So I have the same root, except for this one has a squared on it now, which makes it a double. So you will say x equals 2 double. We wrote this on our resource page yesterday. And that means that you have an x-intercept at 2, 0. And that causes a bounce off of the x-axis. And it can be a bounce from the top or a bounce from the bottom. It doesn't matter. So you can make yours and your picture whatever you want, but just make sure that you have a bounce. And make sure that you can really tell the difference between the first picture we drew for the single root and the second picture we drew for the double root. Do you understand what I mean when I say bounce? And if you want to think about it mathematically, there's a root from this direction and there's a root from this direction, and that's why it counts as 2 of them. So one from the left and one from the right. Okay. You guys can go ahead and set that up. Okay. So this one has a cubed. So we would say x equals 2 triple. And we would say the x-intercept would still be 2, 0, but this is an inflection point. Okay, so we're going to go to 2, 0 again and make our dot, and then come up from somewhere. You can start from the top if you want, it doesn't matter, but make a flat part at the actual root and then keep going. Okay, would you guys agree that that was quite a bit of what we learned yesterday? Okay, there's one piece missing. There's two pieces missing. We talked about degree yesterday, which was really important, and how that determines the shape. But so I know I'm saying this on my video, but if you guys know Cody North, anybody know Cody North? He is a extremely curious, inquisitive child. Love him to pieces. He comes over doing the resource page you guys doing next week. He's like, but Mrs. Todd, what do I do if I don't have Desmos and I don't have my graphing calculator? How do I know to start from the top or the bottom? And I was like, Jody, you're so smart. We're doing that tomorrow. Just hold on. And he's like, I can't hold on. So I had to explain to him early what to do. So that's what we're going to do now is figure out, okay, if I don't have a graphing calculator, because you know your teacher's a jerk and doesn't let you use it all the time. And if I don't have Desmos, how do I figure out, do I start my graph from the top or the bottom? Okay. You guys, I know I told you about my third period. They're, they're, uh, they're, rap, that's the right word. Um, Vocal, but in a good way. Like, you know, super into it. Okay, so we're gonna draw some pictures here. And where you start your graph is going to depend on your A value. Do you guys remember what A value is or where that's located? Okay, I'm going to ask you a prior knowledge question. Can you show me with your hands a parabola with a positive A value? Show me with your hands. Yeah, I was thinking like this, right? Positive A value. Okay, now a parabola. Does that have an even degree or an odd degree? Even, degree 2, it's squared. Okay, all even degree polynomials behave the same way. I want to refer you back, and you do not need to get your packets out. We'll just look at mine. Look at this guy. This guy is degree 4, which is an even number, has a positive A value. You guys see in front of the x to the 4th is a 1 that doesn't really, we don't write, but he lives there. Can you picture him living there? The 1 in front of the x to the 4th. Okay, that's a positive number, which means it's going to open up. Okay, so all even degree polynomials, if they have a positive A value, they're up and up just like a parabola. It's just that they're going to have bouncies in the middle, and we don't really care about that. We care about the general shape. Okay, so if you have an even degree and a positive A, both arrows will go up, and it'll look something like this. The amount of bouncies in the middle doesn't matter. We're just talking about kind of how do you start the general shape. Okay, mathematical powers of deduction. What do you think is going to happen if it has a negative A? What do you have? What does it do when you have a negative A with a parabola? You got like a frowny, right? So something like that. Did we do one of those yesterday on our resource page? You don't have to look, I'm looking. Yup. Here's this guy, 3, 4, which is an even number, and negative in the front. So both arrows are going down. Okay, are you with me so far? Okay. Now, odd degree is a little different. So looking at an odd degree, the first one we did was odd. This guy was degree 3, which is an odd number. His A value, is this positive or negative in the front? Positive. He starts down here and ends up here. I want you guys to think of it like the slope of a line. This is a positive, so it's got a positive increasing over time. So it means it's going to start low and eventually increase. So like this, kind of like a positive slope. Okay, so I'm going to say start down and up. Something like that. Again, the amount of bounties in the middle is going to depend on the problem. Each one will change, but for the arrows part, okay, what do you think is going to happen if A is negative? Yep. Something like that. Did we do one of those yesterday? Yep, this guy. Degree 5, odd number. He started up here and ended down here. A lot of bounties in the middle. That's okay. We're just interested in kind of how do you know where to start. Okay, so that's the notes part. And now I'm going to hopefully tie some of it together. But the first thing I need to teach you is number 25, where there's like a giant, you know what I mean? But if I say like there's an asterisk on something, you guys know what an asterisk is? It's like the little star on the keyboard, and it means like there's a big note you need to know. There's like a however. When you see an asterisk in your brain, you should say like, however, something. There's a however that I need to teach you in number 25. And I'm going to do it in 2 different colors. So if you're a person that likes to put colors in their notes, grab 2 colors for that. Okay, so here's my big however. I'm going to take my graphing calculator and I typed in the top equation, x minus 1 squared at the top. And I just put the other one in here because I want it to be pink because I'm a weirdo. That's not you, it's me. And I'm going to graph that first one. Here's what it looks like. So let's just make a general picture of it. It's vertex is at 1, 0, you can tell, which makes sense if you think about this. You should think about the fact, oh, that's a bounce. That makes sense. So it's going to come down like this. Go up like that. Doesn't have to be perfect. It's okay. No surprise there. It's a parabola shifted to the right 1 unit. No big deal. Okay, now I'm going to add the other one, and you're going to hopefully see what I mean by the however. Oh, crap. That also looks like a parabola. It follows all the same rules as a parabola. So what I'm trying to tell you here is that a fourth power is also a balance. So how can you tell which is which? You can't from just a graph. So let me take this one off. If I gave you this picture, would you assume that that was a parabola? You totally might. I could see that happening to anybody, even me. But that's actually not a parabola. All of the even degrees behave like that. Okay, so what does that mean? So, well, first of all, we're going to try to sketch this I'm going to sketch mine in pink. So it's steeper. I can tell that. That makes sense because it's a fourth power. So I'm going to come down, and then it's actually flatter at the bottom, more like a U shape. So if you have the graph and not the equation, you can only get the minimum degree. So you look at those and you say, well, there might be degree 2, there might be degree 4, there might be degree 6, 8, 10, 12. You're not sure. But you know for sure it's not degree 1 because that would be a line. So there's your however. You really need the equation to be sure about the degree. Okay, is that really going to stop us? No, but it's just something I need to mention. Okay. Moving on to number 25. You're going to have fun drawing now. You get to be an AP art class. Okay, I'm going to use my pink again for this one. So if you're using a different color, grab that again. How can I tell what the minimum degree is from a graph? It's the number of directions. Did I show this to you yesterday on the resource page? Okay, let me show you again. Covering this up, covering this up. What degree is this? 1, 2, 3. Okay, what degree is this? 1, 2, 3, 4. What degree is this? 1, 2, 3, 4, 5. Okay, and then let's do the last one that we did together real quick just for fun because I want to show you how the triple works. What degree is this? 1, 2, 3, 4. The flat part counts as its own change of direction. So 1, 2, 3, 4. Okay, so what degree, minimum degree, we don't know what's happening outside of my little picture, but what's the minimum degree of this one? 3, 1, 2, 3. Minimum degree 3. And is this one a positive or negative A value? Positive, and you can tell it's positive because it's going uphill as you write. Okay, B, what's the minimum degree? 2, 1, 2. Minimum degree is 2. Does this one have a positive or negative A value? Negative, because they're both going down. Okay, for C, I'm going to put it up there. It's got a lot of squiggles. I want you guys to set it up, and then I want you to try to do it yourself. Okay, when you're ready for the spoiler, look at the screen. Minimum degree 5, A is negative. How'd you do? It's not too bad. Okay, we have one more problem to do, and it's very important. It is, so I don't know if you looked on your packet, but we have a quiz next Friday. Next week Friday, not this Friday, next Friday. The very first problem on it is very, very similar to the one we're gonna do next. So I'm gonna pretend like I'm taking a quiz when I do this problem. I'm gonna do the first one with you, A, and then you guys are gonna do B in your groups, and I'll put up the answer. And then I'm going to come around and stamp as much as I can. Okay, you guys, so I'm a student. Look at me, I'm adorable. I come in to take my quiz next Friday. I'm all ready. I sit down and we're just gonna do A together, and then you guys are gonna be in your groups. The directions say state the degree, state the root, and sketch the graph. And remember, you have no calculator. So state the degree, state the root, sketch the graph. Okay, so first thing I'm going to do is state the degree because I need to know that for sketching anyway. And in this one is factored form, so I'm going to count the x's. 1, 2, 3. So this is degree 3. Everybody good so far? Okay. The next thing I'm going to notice is that A is a negative. That's going to help me with my sketch. Okay. My roots are, do you guys see this plain X in the front? That one is 0. And if you want to, you could write X minus 0 if that helps your brain. X minus 0 is just X. This one is X equals -1, and this one is X equals +3. You guys good so far? Okay, so first I figured out the degree. Then I figured out my A value was negative by looking at the front. And then I said it's degree 3, so there should be 3 roots. Okay, I have roots at 0, -1, and 3. Okay, the last thing I need to do is sketch it. And to do that, I need to use the fact that A is negative. If A is negative, so I like to think of odd degrees, kind of like this going, meaning like you have one arm up and one arm down. So if it's an odd degree, there's one arm up and one arm down, but A is negative, so that means it's decreasing over time. So A is negative, so that means it's decreasing over time, which means I need to start high. And you can memorize that if you want to, start up and down. And so I'm going to start high, come through here, and you guys are probably nervous about how like big these bumps should be. I'm not going to grade that, so you don't need to worry about that. But a good general rule is, you see how these are closer together than these two? Then this bump should be smaller than that one, just because these two are closer to each other. And done. Okay, you guys, give B a try. But remember that there's a 2 here, which means there's a bounce. So be careful. You can definitely talk to each other. Speak, please, would be great. Mhm. If there's nothing there, that means it's a 1. I just drew mine wrong. I figured it out now. Woo, I'm special. I fixed it. Okay. All right. When you're ready for your spoiler, I think it's correct now. You just ignore all the white out. It's totally fine. So degree 4, positive A, which means both arrows are up. Come through the first one, bounce at the second, which is 1, and then go through the third. Sorry about my I don't know. I just bounced here for some reason. Because I saw this first and I thought I went left to right, but I didn't, and it's fine. 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 Totally fine. Okay, do you guys know what the homework is? Yeah. It is 32, 33, 34, and 36. Let me put my wonky picture back up. Not good. It doesn't even go through it's fine. Totally okay. Yep, I do. They're over there behind me.